Hi Louisa. Right, I'm looking at question 4 of the calculator analysis, and I've written some stuff out already. So I've got the function that we're given, and if you look on the graph, then there's a couple of coordinates given. So I started off by thinking, right, let's write this function out with the x value that's equal to the y value. When x is 0, y is 1. So that means that this is true, equals 1. E to the power of 0 is 1. So a plus c must equal 1. When x is 2, then the y coordinate is 2e minus 1. So again, I just wrote it out here. At this point, I'm just making a bit of an educated guess, really, because just looking at this function, I'm thinking that if on this side I've still got e to the power of 1, and here it was e to the power of 2b. So I'm just making a couple of assumptions. I'm thinking that the b is more than likely going to be 0.5, a half. A 2 and c equal 1. Basically these numbers here are 2 and the c. But it also ties in with this, like 2 minus 1 give me 1 as well. It's not a very formal way of doing it. It's sort of trial and error. A bit better than trial and error, but anyway, it looks like the right solution. So I'm going to flip. Let's see if this works. Oh, check it out. Right. So now I'm going to go to menu, add graphs. Because the thing is, it's calculated paper, so I can check my answer now. I can make sure I've got it right. Oh, is this going to work? Oh, there we go. Okay. And I'll type in my value there. So what I'm thinking is that, what did I say? 2 times e to the 0.5x minus 1, wasn't it? So that's what I'm thinking. Let's have a look. And that looks pretty good, doesn't it? I think that looks about right. Looks like it's got an asymptote of minus 1, goes through the point 0.1. I could, if I wanted, to double check it even further, is have a look at this. I've got f1 defined now, so if I go to a calculator page and try f1 of 0, see what that gives me. 1, that works. And I can also try f1 of, what was it on? 2, wasn't it? 2, enter. I've got a feeling that's the same as, let's try it, 2 times e to the power of 1 minus 1 and do try and enter. Yeah, there we go. So so I'm pretty confident that that's going to be the function. So I reckon we've done the first one. Right, let's put this on pause, which I've totally forgotten how to do now. Is it that? All right. Okay. So so that's the first part, and the second part was two things happening to the graph. If you start with the original lung graph, that's got the asymptote, it's got the y-axis as the asymptote, and it goes through 0.1. There's been a translation of 1 to the left, and there's also been a stretch, a horizontal stretch of 2. So it's this slightly weird one, isn't it? We have to do it in like reverse, to do the stretch, and then we have to do the translation. So if you look here, I've said, right, well, if I wanted to do the stretch, it would be 0.5x to make a stretch of a horizontal 2, and the translation would be, where did I plus 2? Can't remember. Oh yeah, that's right. Yeah. Sorry, it's translation of 2, isn't it? Sorry, because it's gone to. There we go. That should be. Why isn't it working? There it is. 2 to the 2 to the left. Sorry. So the translation would then be plus x to the left. So we've done the stretch followed by the translation. If I expand this bracket, I get 0.5x plus 1, which is actually exactly the same. Either one's fine. And then again, I'd be tempted to go to my calculator, have a look what it looks like and make sure. I want to type all that in, ln of 0.5x plus 1. Lo and behold, I get the graph that's given to me. So I think that works okay. Okay, is that enough? I hope so. Let me know if not.